Okay, these are the Chapter 11 notes, Systems of Equations. This is page 2. We are going to start with a couple of examples. We are going to solve by graphing. And we definitely want to make sure that we know which graph goes with which. So I'm going to start here with the first one. It's in slope-intercept form, which makes it easy to graph. Y equals x minus 3. Remember that whenever we look at an equation in y equal mx plus b form, that plus b, the minus 3 in this case, tells us where the y-intercept is. Our slope is the number attached to the x. In this case, it's a 1. Remember, if we have no number there. So that means rise over run is 1, or 1 over 1. So I'm going to go up 1 in the positive direction, over 1 in the positive direction. I could use any ratio that gives me a slope of 1, so I could go up 2 over 2. Pretty standard slope here. And we want to be as precise as possible. And my crooked. Which okay, I'm going to try one more time. We're going to blow this up. And see if we can make this a little straighter. There we go. Better. Second equation. 2x minus y equals 6. I don't necessarily want to put that in slope-intercept form, so let's see if we can remind you about how we can get around that. And I'm going to use the space underneath. I can use the intercept, so I want to let x equal 0. My equation becomes 2 times 0 minus y equals 6. Negative y equals 6, so y equals negative 6. When x is 0, y is negative 6. And I should be able to do that with y. We're so used to plugging in numbers for x, we kind of forget that we can also plug in numbers for y. So when y equals 0, x equals 3. These are two separate and distinct points. I'm not going to cram that x and y together. But I have 0, negative 6. I have 3, 0. Well, that's handy. And my solution is right there where those two lines intersect. And that is the point 3, 0. Okay. We know that it works in the second equation. That was our intercept. We can always plug it back into the first. Y equals x is 3, 3 minus 3, 3 minus 3 is 0. So that one works. Okay, let's take a look at B. I'm going to go back to my blue and purple motif. Again, slope-intercept form. So I have an intercept of positive 3. This time my slope is 1 over 2. So every time I go up 1, I'm going to go 2 in the positive direction. Up 1 over 2. Up 1 over 2. And I get this line right here. Sometimes it's helpful if you are graphing a lot to label them if you need to keep track of things, or just use colored pencils and color code here. Other equation, x minus 2y equals 8. Again, I'm going to use the intercepts because I really don't want to solve for y. Let x equal 0. I get 0 minus 2y equals 8. Divide both sides by negative 2. And y equals negative 4. So when x is 0, y is negative 4. And then I'm going to plug in y equals 0. X minus 2 times 0 equals 8. That means x equals 8. And when y is 0, x is 8. So I've got 0, negative 4. I have got 8, 0. And when I graph these, my super straight line there, I end up graphing a line with the exact same slope. If you notice, between any 2 points, I go up 1 over 2. Same slope. These 2 lines are parallel, so there are no solutions. And we'll take a look at what this looks like algebraically a little later on in the notes. Let's take a look at this last one. I have got y equals 3/4 x plus 1. So again, my intercept is that plus 1 part. And my slope is 3/4, so up 1, 2, 3 over 1, 2, 3, 4. Both of these are in the positive direction. Positive 3 is up, positive 4 is to the right. I could also go backwards, go down 2, 3, left, 1, 2, 3, 4. It's all good. And I get this line right here. When I go to graph our other line, negative 3x plus 4y equals 4, intercepts are not going to be as nice this time, but I can try. I got let x equal 0. Negative 3 times 0 plus 4y equals 4. When x is 0, y is 1. And when y is 0, I get negative 3x plus 4 times 0 equals 4. Negative 3x equals 4. X equals negative 4/3. So I've got 0, 1, it's this point right here. I have negative 4/3, it's this point right here. I end up with the exact same line. So here, we have infinitely many solutions. Solved by graphing. That's great. if you've got numbers that are easy to work with, and if we've got solutions that are whole numbers, not always fabulous though. Because if my solution is the point -5/13 and 121/8, there's no way I'm going to pick that out on a graph. So we go to method number 2, the substitution method. I have two equations, they're both linear. I am going to solve for a variable in one of these. I'm going to take this one, and I'm going to solve for y. So I'm going to add x to both sides. Y equals x plus 3, or 3 plus x, it doesn't really matter. So now I'm going back up to the original equation, and I am going to take this y that I just solved for, right here, and I'm going to plug it into this equation for y. Keep in mind the goal of solving a system is to find the x and y that are the same in both equations. So if in my second equation y equals x plus 3, y better equal x plus 3 in my first equation too. We're going to use some algebra to distribute here. I got 3x plus 2x plus 6 equals 11. Combine like terms here, I got 5x plus 6. I'm going to subtract 6 from both sides. X equals 1. Now, I still got to figure out what y is. So I'm going to take this 1, and I'm going to plug it back into this equation. Y equals, my x is 1. I get y equals 4. So my solution is the ordered pair 1, 4. And now what I'm going to do to make sure that works is plug it back into the top equation and solve just to double check. So here's our solution, the ordered pair 1, 4. This is where those two lines are going to intersect.